Hello everyone, this is Ray over at CigarClimatology, and today what we're doing is a very brief video on the Generation 13 Control Center Assembly. Now, I'm going to do a separate video about unpacking this assembly depending upon ultimately how I pack it. There are a number of sensitive terminals here on the secondary controller. This is in fact the secondary controller assembly, and it has three connections. Okay, one is the power connector, which is up here at the top, and you need to make sure that these connectors are actually put in the correct way, and I'll cover this a little bit more on the video. And that generally means that the wires, as you see them here, are actually at the top of that connector assembly. Okay? Now in this particular case, there are several portions here which are not a part of your assembly, which includes this switch block and includes this little simulator. Okay, so what I'm going to do though is I'm just going to give you a brief overview of how this system generally works, and remember that this system, that the secondary controller actually takes charge after the primary controller issues a command, and this controller is a secondary processor. And what it does is it actually performs a greater, a more exacting function, and it allows me to do a number of different things through this controller which cannot be done through the primary controller. So this allows me to, again, to take functional control of the raw digital output signals and process them in such a fashion that we get better performance out of the system. I'm not going to dwell on that a whole lot. But first and foremost, there are a number of lights down here and a number of lights here. The flashing light here indicates that we do in fact have the necessary voltage. Now these controllers run off of 5 volts. That power supply is actually in this assembly down here. Whatever you do, you don't want to plug this thing into the 12 volt system here, because that will shoot it to hell, and you don't want to do that. Remember, this will all come pre-wired for you, but the connectors will be off, and again I'll go over that in a subsequent video. The number 1 switch, or the number 1 digital output in our primary controller, is represented by this switch. And what has happened here is I've gone ahead and switched that on as though the refrigeration was asked for. This is a 110 volt signal. That's why the 110 volt lamp. And you can see that that is now lit. Now after a period of time, the actual evaporator coil fan will come on, and that's represented by this red light which you've just seen. And you'll notice that these are timed events. And while I'm not going to go over each individual timer, there's many timers in this system currently, and they do many things. The key really here to understand is, just because your primary controller might be asking for a function, the secondary controller might already be considering what it has done or is going to do with that function based on other functions. For example, the humidification. The humidification is signified by this 12 volt fan, and perhaps you've noticed something. When the fan comes on, the evaporative fan actually goes off for a period of time. Okay, again, this helps the performance function of the system. And again, it's designed to make sure that we don't get excessive dehydration or excessive hydration in the system under certain circumstances. Again, I'm not going to go over every single one of these functions, but you will notice that certain things will happen inside your cooler if you start really examining them closely, and these are not defects or problems. They're actually what the secondary controller is designed to do. For example, now that this fan is running for a period of time, in order that we get better cooling and less dehydration, you'll notice that the evaporator fan is toggling on and off. This is actually based on an internal clock based on milliseconds, and it's empirically derived. So this is just not a random event. This runs so many thousand milliseconds on and so many thousand milliseconds off. Again, it's just something that's been empirically derived. Now let's take, for example, that the cooler has now been shut off, the refrigeration system. You'll say, well, why is my cooler still running? Again, this is an internal function design, and it's based on empirical testing and in an optimum run-on for the cooler. Again, this is just a design of mine and something that's been empirically tested to make the system run better. So just because the primary controller has said enough is enough for the refrigeration system, it doesn't mean that the refrigeration system will be off immediately. Now in this particular case, you'll notice that there's some toggling on and off of the humidifier fan. Again, another programmed function. Now here's something that you will also note. We need to protect a compressor cooler from running off and running on and running off in too quickly a fashion. So if I go ahead now and I turn this switch back on, you'll notice that I do not get an immediate response from the cooler. And this is the anti-short cycle relay. This is something that locks out the cooler and keeps it from restarting under head pressure, which can damage the compressor system. You'll notice here that I still do have my small number 1 light. I don't know whether you can actually see that. But this light is on, representing that the signal is being received by the secondary controller, but the secondary controller is simply not acting on it at this point in time due to the fact that it's waiting for a certain timer to allow it to function once more. The heater assembly is on the number 2 relay, and you can see that the heater assembly will generally get toggled on and off at will. But typically the heater assembly will be locked out for a period of time after cooling. So again, these functions are part of the firmware and how this particular controller is programmed. So you might have a case where you get a lot of cooling in one cycle where it essentially overcools the interior, and then it might ask, the secondary controller might ask for heating, and in fact you might not experience any, and that might be due to the design and the software making sure that we don't have a sensor bounce, or where it bounces between heating and cooling and drives the system to a warmer state, where in fact the ambient will provide that warmer state for you. It just protects the system from unnecessary bounce. So that's kind of an overview of what you can expect in the system. The number 4 function is the dehydration function, and again you'll notice nothing has happened here because that's also currently locked out due to the fact that we're waiting on the anti-short cycle relay. It also will run the evaporative cooler at a different setting than the refrigeration side. Again, these are all things which just help the function of the cooler. So that's an overview of the system. There's something also interesting that you'll notice, that going back here now to dehydration, I get nothing out of it. That's because the system has recently run, or at least according to the software or the firmware, it thinks that it has run in the dehydration mode, so the humidifier is temporarily locked out in order to keep you from now over humidifying a system that's already recently called for dehumidification. So there are a number of lockouts, there are a number of things in the system which keeps the system from doing silly things and wanting to bounce, which really allows us to tighten up the controls in the programming, and makes the cooler, makes the formal humidor run within a much smaller band of control which keeps us closer to our set point in relative humidity, and it keeps us closer to our set point in temperature. Since I've been talking here for a while, we can see actually whether or not this has re-triggered. Nope, I have not run the necessary seconds yet, and that's the reason why this guy has not reset. But instead of sitting here watching it, I'm just going to go ahead and wrap up the video here. And when you guys get your system, obviously you can sit and observe and see how the system works. But this is a way that I do bench test your system prior to you getting it to make sure that all the functions work the way that they're supposed to work. And I will typically have run your system 24, 48, or 72 hours depending upon how much time I actually have to deliver your system. Now, we went ahead and we left this call for refrigeration on as soon as the anti-short cycle relay cleared. You'll notice the light came back on. Again, you don't see this timer, but the timer does exist. It's now waiting again for the evaporator cooler fan. There's the evaporator cooler fan, and now your system is again refrigerating. So that's the gist of how the system works, or some of what you'll see in working. There's a lot of programming in here, and I just barely touched the surface of it. But it should give you a little bit of an example about how sophisticated these systems really are, and how much empirical testing goes into to producing one that gets the precision that I'm able to get. Thanks a lot for watching. I hope you enjoyed the video.